Hello, welcome back. Today we are going to do a quick review of 1 degree and 2 degree alcohols. Now for 1 degree alcohols, this is the structure. We know alcohols have hydroxy group, the OH group. Right, for 1 degree alcohol, the hydroxy group that is attached to the C has 2 hydrogen atoms. And this C is only attached to one alkyl group. Now, this alkyl group can be methyl group, CH3, or it can be longer, C2H5 or C3H7. It can be ethyl or it can be propyl, okay? So the chain length can increase depending on what type of alcohol. But for a 1 degree alcohol, the C that is attached to the hydroxy functional group has 2 hydrogen atoms attached to the C, okay? That is attached to the hydroxy group. And the C that is attached to the hydroxy group has only one alkyl chain, okay, alkyl chain that's attached to the C. So it undergoes a 2-step oxidation, okay? You can tell by the 2 arrows here, it undergoes 2-step oxidation. Now, if you want to obtain the aldehyde, you will require distillation, okay? So you got to heat this 1 degree alcohol in the presence of an oxidizing agent, acidified oxidizing agent, and partially oxidize these to form an aldehyde. So you can't allow it to completely oxidize to form the carboxylic acid, so you got to distill it. Okay, you got to distill to obtain the aldehyde. Now, what if you want the carboxylic acid? Then you will have to reflux. Now, reflux is a process of heating and condensing until the primary alcohol is converted into the carboxylic acid. This is to ensure that complete reaction occurs. So if you want the carboxylic acid as the final product, then you wouldn't have to distill. You would have to reflux. Okay? And now let's look at the secondary alcohol. The secondary alcohol is very different. It's very different from the 1 degree primary alcohol. You can tell that the hydroxy group that is attached to the C, okay, this C here, is attached to 2 alkyl groups. Whereas for primary alcohols, the hydroxy group that is attached to the C is only attached to 1 alkyl group. Now, these alkyl groups can be same, maybe the same, maybe same, which means that they can be methyl groups, CH3, CH3, or they can be different, okay? The chain lengths of these R might be different. So I use a R prime to show that this chain length is different from this. This could be a methyl group, this could be an ethyl group. So this is CH3, this could be C2H5. You will also notice that the C that is attached to the hydroxy group is only attached to 1 hydrogen. Whereas for the primary alcohol, the C that is attached to the hydroxy group is attached to 2 hydrogen atoms. So for secondary alcohols, the process is more straightforward. It's just simply reflux because the final product is a ketone. So in the oxidation of a secondary alcohol, you only get one product, okay? You only get ketone. And ketone, we can see that it has C double bond O, and this C double bond O is bonded to 2 different alkyl chains, right? This could be CH3 and this could be C2H5. So 2 alkyl chains, and ketones cannot be further oxidized. Okay, I didn't show you the tertiary alcohol, 3 degree alcohols. The reason is because tertiary alcohols do not undergo further oxidation.